In this short video, we'll do an example of hypothesis testing for one population proportion, and we'll ask the question, do more than 41% of Wisconsinites like cats? This is a research question about the proportion of Wisconsinites who love cats, and we want to know, is it more than 0.41? So let's say we collect some data, and we find that in our data, 450 out of 1,000 Wisconsinites like cats. So that's a sample proportion, p hat of 0.45. That's more than 0.41, but maybe that's just due to chance. It was a random sample after all. So we ask the question, if p actually is 0.41, if the population proportion is 0.41, how likely is it that we would find p hat of 0.54 or more just due to random chance? So first we're going to answer this question by doing a simulation. So let's simulate a situation in which the population proportion is exactly 0.41, and we survey 1,000 people, and we're going to simulate doing that 500 times. So we're going to pretend that 500 researchers all went out and surveyed 1,000 people in our population where the proportion is actually 0.41. So 500 researchers, that's our 500 up here, are each surveying 1,000 people, and the proportion is actually 0.41, which would be 410 out of the 1,000. And let's see how many of the numbers that we get are at 0.45 or higher. So if we filter those, or sort those from largest to smallest, we see that out of the 500 simulated surveys we did, only 4 of them came in at 450 or more. So only 4 of the 500 had sample proportions of more than 0.45. And 4 divided by 500 is 0.008. So if the proportion of people in the population who like cats is only 41% or 0.41, then the data we collected when we surveyed 1,000 people would only happen 0.8% of the time. That's not very likely. It makes us think, okay, it must be more than 41%, because the data we collected in our example, 1,000 people, 450 liked cats, would be very, very unusual. So let's go back to the theory. Remember, we're asking ourselves this question. If p is 0.41, how likely is it that we would find p out of 0.45 or more? In our simulation, it was less than 1% chance. Now let's look at the theory. A theory for the sampling distribution says that if p equals 0.41 and n equals 1,000, then for different sample proportions, the mean is 0.41 and the standard deviation is 0.0156. So the z-score that goes with our data would be 0.45 minus 0.41 over 0.0156, which is 2.56. With the help of Normas dist, we find that the probability of getting a sample proportion that higher is 0.005. So if the population proportion was 0.41, again, the data we got when we surveyed 1,000 people would be very, very unusual. This makes us think that the population proportion is more than 0.41. If the proportion of cat lovers in Wisconsin were not more than 0.41, the data we observed would have occurred only about 0.5% of the time. Our data was statistically significant, unlikely to be due to chance. Now with our procedure template, we can get Excel to do the number crunching for us easily. In this example, our hypothesized proportion was 0.41. Our sample size was 1,000. And our sample proportion was 0.45. So there's our z-score, 2.57. And our hypothesis, our alternative hypothesis, was of the form proportion is greater than 0.41. So that's this one. And there's our 0.005. So here we see that Excel takes the number crunching pain for us away and gives us p-value, the probability that we would get data like we got without much trouble. So again, the moral of the story is we started with a question, we collected some data, and we asked the question, if the null hypothesis is correct, if the proportion actually is 0.41, how surprising would our data be? The answer was very surprising, and so we decided that more than 41% of people liked cats. Notice, by the way, if our sample size had been only 100 and the data was exactly the same, then it wouldn't be terribly surprising. We would have had a 21% chance of getting data like that.